Hey guys, welcome back. So in the last video, we were introduced to the topic algorithm runtime analysis. So in that video, we learned what is algorithm runtime analysis and why do we need to learn it. Hope the idea was clear. Now in this video, let's talk about the annotations that are used to measure performance of any given algorithm. Now before doing that, let's try to understand how do we measure performance of a car. So a performance of an algorithm is no different from a performance of a car. So let's first understand it with the help of a car's example. So let's say this is a car that we are interested in buying, and we also need to know what is the mileage that this car returns, or in the other words, how much distance this car can cover in 1 liter of petrol. Now when we ask this question to the salesman that what is the performance of this car, how much mileage this car can give, so we were expecting a single answer from salesman, let's say 15 kilometer in a liter. But surprisingly, the salesman gives us 3 answers. He says that it can run 10 kilometer in a liter, it can also run 20 kilometer in a liter, it can also run 15 kilometer in a liter of petrol. Now that might be surprising. Now why did he give 3 answers instead of 1? So the reason is that he has taken into consideration 3 different driving conditions. That is, how about if we run this car in city traffic? What happens when we run this car on a highway? Similarly, what happens in case of a mixed environment? So when we are running this car in a city traffic, it might return us a mileage of 10 km. On a highway, it might give us 20 km. In mixed environment, where we are riding the car in city traffic for some time, on highway other times. So on an average, it might give us 15 km per liter. Now you see that the same car with the same petrol, just depending on the driving conditions, can return us 3 different mileages. Now similarly, in case of an given algorithm, we can measure its performance in 3 different notations. That is, what is the best case scenario, what is the worst case scenario, and what is the average case scenario. So an algorithm in the worst case, let's say it takes 1 minute to execute. The same algorithm in the best case might take only 15 seconds to execute. However, on a large sum of data, on an average, the same algorithm can take somewhere around 35 to 40 seconds to execute. Now notation helps us in defining the best case, the worst case, and the average case. Fine. So I hope you have understood on a very high level that what is an annotation of algorithm runtime. Now let's see what are those 3 annotations. Now the first annotation is an omega. Now what is an omega? So omega notation gives the lower bound of any given algorithm. Now what do we mean by lower bound? In layman's language, we can say that for any given input, the running time of the algorithm will not be less than the given time. That is, we guarantee that whatever kind of an input that we give to the algorithm, the processing time for that will not be less than the given time. Let's say we are trying to sort 1000 numbers. Now when we say omega, we mean that whatever this 1000 numbers can be, it will never sort in less than 10 seconds. Of course, it can always take more than 10 seconds, like 15, 20, 25 or even more than that. But it can never go down to 9 seconds or 8 seconds. Now you might be wondering that why do we need this notation? So the answer is simple. So sometimes what happens is we need to know that for any given algorithm how much time minimum is required so that we can assign the resources accordingly. So in those kind of cases we need omega. Now let's see what is the next notation. So the next notation is called big O. So it is a notation which gives the tighter upper bound of a algorithm. Now what does that mean? In a layman's language, it simply means that any given algorithm will not take more than the given time. That is, let's say if we have 1000 numbers to sort. Now when we say big O, it means that maximum this will take, let's say, 100 seconds to sort this 1000 numbers. It cannot in the worst case exceed 100 seconds. It will never go to 101 second. Of course, it can always go to, let's say, 90 seconds. But it cannot go more than 100 seconds. So you see that there is a contrasting difference between omega and big O. In case of omega, we were saying that in any kind of a cases, this algorithm will not take less than a given time. However, in case of big O, we are saying this algorithm will not take more than any given time. Now you might be wondering that why do we need big O? Now we need big O in those kind of situations where we need to guarantee that the time taken to execute the algorithm will not exceed the given time. Now let's say we are implementing an application for the airbag system in a car. Now in that kind of a cases, we should always measure the efficiency of that algorithm in terms of big O, because we need to know that in the very worst case, how much seconds does the system takes to deploy the airbag in case of an accident. So let's say ideally it takes 2 seconds, but sometimes due to some technical reasons it might take 2.5 seconds, but it does not takes more than that. So those kind of cases we can define with big O. Fine. So I hope you have understood big O notation. Now let's see the next notation. Now the third and the last notation is a theta. Now what is theta? Theta basically decides the upper bound and lower bound of any given algorithm if they are same or not. Now what does that mean? It simply means that on an average how much time does a given algorithm takes. So previously we said how much minimum time it takes. In case of big O we said how much maximum time it takes. But in case of theta we say how much time on an average it takes. That is, let's say if we want to sort 1000 numbers. Now let's say it takes 10 seconds to sort this 1000 number. Now if we run this algorithm again for some different input, it might take, let's say, 11 seconds. Now if we run this algorithm again for some other input, it might take, let's say, only 7 seconds. So you see that there is a variance in the performance. So theta basically tells that what is the average over here. Let's say the average comes to 9 seconds. So theta will say that the average performance of this algorithm on a very huge set of inputs will be 9 seconds. Fine. So I hope you have understood what is theta notation. So in this video we learned 3 notations, that is omega, big O and theta. Omega basically guarantees the minimum time that the algorithm will take to execute. Big O guarantees the maximum time that a given algorithm will take, while theta guarantees that on an average for a huge set of data, how much will be the performance of the given algorithm. Fine. So that is all for this video. In the next video, let's see how does the search operation in a 1D array can be represented with these three different notations. Okay. Thanks for your time. See you in the next video.